Hello ladies and gentlemen, and welcome back to another AP Environmental Science screencast with your teacher, Mr. Stano. And today we're going to start talking about water. Water has a huge importance in our lives. It keeps us alive. It moderates climate, which we have seen. It does a number of things with weathering and erosion. I mean, really, it does a huge amount for us. And some things that are maybe not so good for us, such as moving pollutants through different areas. But whatever the case may be, water plays an integral part in our lives. We've seen in class that really there's only a very small or minute amount of fresh water that is available to us. Less than 1%, or what we see here is about 0.02% of fresh water is actually available to us to use of Earth's water supply. So not much there. We could take a look at the different countries and compare populations to the actual amount of water that they have. And here we are, North America and Central America right here. So small part of the population, but we control a decent amount for our population size of the actual fresh water. So we're pretty lucky in that regards compared to some areas around the world where it's not looking as good. There are a number of different factors or different ways that water will basically make its way into the ground and travel. And we're going to talk a little bit about those as soon as the diagram comes up, where we can really look at the little parts of the water cycle a little bit more and how water really moves. Water that's stored in the ground is known as groundwater, pretty easy to remember. Water does not sink into the ground is going to be known as runoff or surface water. And how that runoff gets channeled and directed into other bodies of waters is known as a watershed or drainage basin that we're going to see here. So there's definitely a number of things that we have to look at. So we have our precipitation, we can have our runoff. So this is water that has not infiltrated or percolated into the ground. Our recharge area that we're looking at for this aquifer, water infiltrates, which means it goes into the ground and then will percolate as it moves through, and then we have groundwater flow as we move through. So runoff going over. Infiltration is the process of moving into the ground. Percolation is that downward movement of water into the ground. Now we see we have a confined and unconfined aquifer. A confined aquifer is trapped between two impermeable layers of sediment or bedrock that could be in this area. So these would be very similar to our Magathy and Lloyd aquifers on Long Island. Our unconfined aquifer would be similar to our upper glacial. And you can see basically this water infiltrates into the ground and is able to make it into that aquifer. We have our water table in this region right here. Now this is all a game of sediments. Depending on your particle size and the types of sediments, it will either make up a confining unit or an unconfined aquifer, and how it will judge and dictate how that water flows. But these are just different parts of the water cycle we're seeing here playing into our groundwater. So we currently use more than half of the world's reliable runoff or surface water, and we're using a huge amount of it. About 70% of the water we withdraw from rivers, lakes, and aquifers is not returned to these sources, which is an issue. Agriculture plays a huge role in diverting and using our freshwater systems. And we can see here industry. Now industry is going to include everything from electrical generation, where we use water to produce steam or as a coolant. And then we have residencies. You can see it's only 10%. It's a real small amount that we're actually using. So we're looking at two graphs here, average precipitation, and then basically areas of where the population concentrations are. And you can see that we do get a huge amount of rainfall in these areas here in New York State, over 44 inches, 45 inches, and we have about 8 to 10 million people living in that area within New York City and Long Island. So definitely a high strained area, but we get a good amount of precipitation to recharge that groundwater flow. Other areas, like we go towards Georgia, they have been in drought for a while, or out west, same thing, they've been in drought. These are different areas that might experience conflict in the upcoming years for freshwater use. And an area of particular concern is out here in California, between northern and southern California, where they want to divert the water from here, or whatever water is in this area, to the southern parts. This transfer of water has raised quite a bit of debate, and we'll be talking about that later on. So 41% of the world's population lives in river basins that do not have enough fresh water. So those basins, this area where this water collects, are getting stressed and strained, and people believe that fresh water, or access to fresh water, will become one of the hugest issues that people will have to face. What we're seeing are rivers running dry, lakes and seas shrinking, such as the Aral Sea, which is a very prominent one. Lake Victoria. These areas we're seeing these inland seas and these lakes shrinking, getting smaller and smaller, and also falling water tables and overpumped aquifers, which could be an issue on Long Island. So it is a potential. These are looking at just different river basins and the stress that we have on them, and we can see here that a lot of these areas are stressed, and especially areas where we have a lot of people. There's a debate between whether we should privatize or have municipalities own our water supply. Here on Long Island, it's municipally owned. There are some small pockets that are privately owned, but for the most part, we have our Nassau County Water Authority and Suffolk County Water Authority, municipally owned. There are definitely some bonuses to that, such as the water supply is going to be relatively cheap for us, but there's a little bit of bureaucracy in it. So as we add levels of government into it, typically things don't run as well. But it has been working for us quite well. We have some of the best water in the nation, so things are going okay. The argument for privatization is that these companies work on being more efficient. But what may happen is they might be able to drive prices up because of that. So there's a little bit of an issue there, and it's definitely quite a big debate. So what we do see, though, is with agriculture, this is where our biggest problems with freshwater. Farmers are straining water supplies immensely, pumping from rivers and aquifers, dropping that water table down. Countries that have issues with water supply, we see them importing grain because agriculture uses so much water. It's easier for them and cheaper for them and less stressful on their water systems, so they import grain or any other agriculture into the area. And an issue, which I think is not beginning to be as much of an issue, is when we're using crops to produce biofuels. It kind of comes and goes in waves, but I think the consensus is that right now that biofuels aren't really a huge impact on it. Our water options are, we can get water from aquifers, like we do here on Long Island. We can desalinate ocean water and waste less water, or use surface water. So withdrawing groundwater to increase supplies. Here on Long Island, groundwater, this is where we get it's our sole source, is where we get our water from. They're considered renewable resources unless we're removing water faster than it can be replenished, faster than that water can infiltrate and percolate into our aquifers. Groundwater depletion is or can be an issue here on Long Island and in a number of different areas, basically from irrigation. So there are some advantages. Basically, groundwater, it takes years for that groundwater to move through depending on the sediment. And as it does that, certain pollutants and toxins have affinities for that sediment, and actually it will get pulled out, and the water basically gets filtered as it keeps moving through. There's no evaporation losses, which is huge. And it's cheaper to extract than most surface waters. We don't need to build dams and reservoirs to hold that water back, and it's available year-round. There are problems, though, that we can see from overpumping. We can get subsidence, so where the land will actually start caving in. Polluted aquifers, if they do get polluted, will stay polluted for a while. Saltwater intrusion. This is a potential issue here on Long Island that we have to worry about. And increased cost if we have to clean up this contamination from deeper wells. So here we have our areas where we have groundwater depletion just around the United States. And this is the diagram I'd really like to talk about a little bit more in detail. So typically we have our water, infiltrates, percolates into the ground. Here's our water table. Notice around these areas where the wells are, the water table dips in. These areas, that is known as a cone of depression. Now, typically what happens is the fresh water will exert pressure moving out, and that's what this dotted line is, this normal interface, and it'll stop the salt water from coming in. By pumping this water, this fresh water, up and through, by pumping fresh water up, now this interference or the pressure that's exerting out on the salt water is less and allows that salt water to come in. Pump too much, and you can actually pump that salt water into these wells, and that is known as your salt water intrusion. So we have our cone of depression right around our wells. Salt water intrusion, as that pressure gets relieved off, that freshwater pressure gets relieved off. And then, of course, as we pump water, our water table will drop. So this is just a number of different things that can happen, and pretty much on Long Island, we are experiencing these. Another thing I'd like to add is with these wells. If you can see here, this well is pretty close to the water table. What may happen eventually is that as this well keeps pumping, the water table goes below that well, and now this is dry. One way that some countries, what they do to alleviate this is then they'll start drilling deeper wells, and then of course they'll have a cone of depression here, and then if the water level drops too much, then this one runs dry. So we do see this is an issue, especially in areas in India where they put in a lot of smaller and sometimes illegal wells, and we see that wells going dry one after the other. It's because that well now is higher than the water table itself. Sinkholes, like I mentioned before, basically as we pump this water out, the pore spaces, now there's nothing keeping that pressure out between the sediment, pump out the water, and now we have air pockets in there, and everything can sink on in. And so this is a pretty massive sinkhole here. We hear about them definitely on Long Island. We'll have them from time to time. Down in Florida, where it's at limestone bedrock, that happens. Out west, we also see it too. This is groundwater pumping in Saudi Arabia, and you can just see here on the right-hand diagram, these are all the areas where it's irrigated. So groundwater depletion, some issues. Waste less, what we can do, waste less water, conserve every drop of water that we have, subsidize water conservation, which is a big deal, so that if we pay people not to use water, keep it around water. Ban new wells in aquifers near surface waters, buy or retire groundwater withdrawal rights in critical areas, and then do not grow intensive crops in a dry area. Probably one of the biggest lessons learned right here is this, with the arrow C. Okay, other options are using dams to supply more water, but we'll save that for another day. Hope you enjoyed this screencast. Bye for now.